atomic structure, and elements are made up of atoms. Atom is the basic structure of any element. And in this chapter, we are discussing about atomic structure. And when elements combine together, they form compounds. But again, the basic unit is atom. An atom consists of proton, neutrons, and electrons. Protons are protons and neutrons are inside the nucleus, while electrons revolve around the nucleus. These electrons are in a specific energy level or shells, and proton carry positive charge, electron carry negative charge, and these two charges are the amount of charge is the same, like the same quantity of charge on proton, and you get the same quantity of charge in electron. The signs are different, like protons are positively charged, electrons are negatively charged, but the quantity of charge is the same. Neutron, on the other hand, are neutral, they carry no charge. And if you compare the sizes, one uh, proton is 1836 times bigger than that of an electron, or you can say an electron is 1 over 1836 times of a proton. Uh, this 1836 sometimes rounded off as 1840, and some other place in past year paper I found 1836 as 2000. That's also acceptable. So instead of 1836, you can also find 1 over 2000. So electron is a 1 over 1836 times of a proton. Proton and electron carry the same amount of charge, and but there's a difference in size, as I pointed out. Electrons exist in specific energy levels or shells, and these are the shells K, L, M, N, O, P. K shell can hold 2 electrons, L shell can hold 8 electrons, M 18, N 32, and so on. Why I'm not writing further, because it's not relevant in O level. In O level, only first 20 elements are in the syllabus. So in that case, you have to go like 288. This way you will make electronic configuration. And like in the first shell, there are 2 electrons. In the second shell, there are 8 electrons. In the next shell, there are 8 electrons. And that's it. You have to develop some understanding of periodic table. All more than 100 elements are listed in periodic table. This periodic table is given to you in final exam. So you should know how to use it during your examination. Uh, right now you're looking at the periodic table, and these pink elements are non-metals, while rest are metals. So most of the elements in periodic table are metals, while very few are non-metals. Elements in periodic table are arranged according to their proton number, actually in increasing order of proton number. Proton number are increasing from left to right. If you consider vertical columns, these are groups, like these are groups. And if you consider horizontal rows, These are periods. So vertical columns are group and horizontal rows are period, and uh, a group number actually tell you the number of electrons in the outermost shell. For example, in group 1, the number of electron in outer shell is 1. In group 2, the number of electron in outer shell is 2, and so on. Period tell you about energy level, and suppose an element is in period 3, this means it has 3 energy levels. Isotopes are atoms of same element with different number of neutrons but same number of protons. Since chemical properties depend upon number of electrons, so in isotopes we have some difference in physical properties, but since number of electrons are same, so there is no change in chemical property. This is the periodic table given in the syllabus, and in each box you will find two numbers. One is a smaller number and the other is a bigger number. The smaller number is the number of protons and the bigger number is mass number, which you can take it as proton plus neutron. For example, magnesium 12 and 24, the 12 is the proton number and 24 is the mass number, and the number of proton and electrons are equal. So in this case, if the proton number is 12, this means that number of electron is also 12. Question number 3. Which row gives the number of protons, electrons and neutrons of an atom of zinc? If you follow your periodic table, you will notice that there are two numbers given in the block of zinc. One is 30 and the other is 65. 30 is proton number, so you can interpret there are 30 protons and therefore 30 electrons. Proton and electrons are always equal. Because a neutral atom, proton and electrons are equal. And number of neutron is 65 minus 30, which is 35. So you can choose which choice is according to your working, so it's choice A. Which particles have the electronic configuration of 288? There are 4 cases. One is argon, one is aluminium ion, one is sodium ion, and one is chloride ion. So you first of all have to find all these argon, aluminium, sodium and chlorine in the periodic table, and you have to draw their electronic configuration. For example, if you take argon in the periodic table, the smaller number is 18, which means protons are 18. So therefore electrons are also 18. And neutrons are not required, 40 minus 18. And if you draw electronic configuration, keeping this 18 in mind, it will be 288. Then come aluminium, 3 positive. And before moving to Al3 positive, you should know what is the electronic configuration of aluminium atom. It's a neutral atom. The smaller number is 13 and the bigger number is 37. So there are 13 electrons, and if you draw electronic configuration using 2888, so 2 electron in the first shell, 8 electron in the next shell, and there are 3 left, 3 electron in the next shell, third shell. But if you take 3 positive, aluminium 3 positive, then these 3 electrons are lost to some other atom. and the resulting electronic configuration is 2,8 for Al3 positive. Then come Na positive. In periodic table, Na is 11 and 23. There are 11 proton and 11 electrons. Electronic configuration will be for neutral atom 281, and for this positive ion, one electron is lost. So you have to remove one electron from here, and you get 28 Na positive. Cl negative, chlorine is 17 and 35.5. So there are 17 proton and 17 electrons. And for 17 electrons, the electronic configuration is this. But for Cl negative, we can say that one electron is gained because it is negative. Proton and electrons are not equal. There is one extra electron in chlorine. So if you add one electron to this will be 8. The question is, which particles have electronic configuration of 288? So you have drawn all electronic configuration. Now you have to sort out which one is 288. So one is this Cl negative 288, and the other is argon. So the correct option is B. Next question. A sample of element Q has two isotopes. These are the relative atomic masses and their abundance. One is 65% and the other is 34%. Now if abundance is given to you, then how you can find relative atomic mass? It's simple. Multiply their masses with the percentage and then divide by 100. So the correct option is A. Next question. The atomic structure of four particles W, X, Y, and Z are shown. Which particles are isotopes of the same element? Remember that isotopes are atoms of same elements. They have same number of protons and but different number of neutrons. And identity of an element is the proton number. Like since number of electron can change, an atom can gain or lose electron. So identity of an element is actually the number of protons. And in periodic table, elements are arranged in increasing order of proton number. So you have to sort out where proton number are same. So these are the two places where the proton number is 2, and you will see that the neutrons are different. So W and Y, this is the correct choice. Which statement explain why isotopes of the same element have the same chemical properties? And chemical property of an element depend upon number of electron in the outermost shell, and since in isotopes number of electrons are same, so the chemical property will not change. In question number 4, the correct option is A. They have the same number of outer shell electrons. Question number 5. Nitrogen forms a nitrite ion with the formula N3 negative. Which particle does not have the same electronic configuration as the nitrite ion? Once again, you have to draw electronic configuration of all the elements given in the choices, and then you compare. Like first of all, for N3 negative ion, you have to draw the structure of nitrogen, neutral nitrogen. So the proton number is 7, electrons number is also 7. So configuration is 2, 5. But you are drawing 3 negative ion which means 3 electrons are further added to this. So resulting configuration of N3 negative is 28. Likewise, you go to aluminium, proton number is 13, mass number is 27, and if you draw electronic configuration of this neutral atom is 283 to make 13. And if you draw 3 positive in which 3 electrons are lost, so it makes sense that this third outermost electron is lost to some other atom. So resulting electronic configuration is 28. Then come to Cl negative. Before moving to Cl negative, first draw the structure of neutral chlorine, which is 17 and 35.5. Electronic configuration is 287, and since it is negative, one electron is gained. So the resulting electronic configuration is 288. Then comes sodium, Na positive. The electronic configuration of neutral sodium is 281, and for Na positive, one electron is lost. So the resulting configuration is 28. O2 negative. Neutral oxygen is 816. Proton number is 8. Electron number is also 8, so it's 26. And when it comes to iron, O2 negative, 2 electrons are definitely gained. So the resulting electronic configuration is 28. Now the question is, which particle does not, so very interesting, does not have the same electronic configuration as the nitride ion? And we know this is the standard, this is nitride ion, 28. So you have to see which one is matching and which one is not matching, like Al3 positive is matching. So you are not interested in this. Cl negative is not matching. So of course this is your choice. You are looking for this. And Na positive is also matching. Nitride is 28, so this is also 28. We are not looking for this. O2 negative is 28. This is also matching. So you're not looking for this. So there is one which is not matching. This is chlorine, Cl negative. And Cl negative is in B. So the correct option is B. Yes. Next question. Atoms are made up of protons, neutrons, electrons. Atoms of the same element are known as isotopes. Complete the table. These are the relative charge and relative masses, and you have to learn all these things. Relative charge of an electron is -1, neutron is 0, proton is +1, and relative mass of an electron is 1840 times of protons, so it is 181 over 1840. You have to learn this number. Relative mass of a neutron is 1, proton is 1, and Mg24 and 12 and Mg2512 are two isotopes of magnesium. You have to fill the table. If I give you these numbers, you can easily predict the number of electrons, number of neutrons, and number of protons. We have done it before. So this is the working. You can fill the table following this working. Explain why magnesium ion have a charge of 2 positive. It has charge of 2 positive because proton and electrons are not equal. In Mg2 positive, there are 2 more protons than electrons. Remember, in a neutral atom, proton and electrons are equal, but in case of ions, the proton and electrons are not equal, and since it is 2 positive, this means it has 2 extra positive charge compared to electrons, and this is what you have to write. Magnesium ion has 2 more protons than electrons. Mg2 positive ion have the electronic configuration of 2,8. Give the formula of the following particles which have the same electronic configuration as Mg2 positive. Now you have to refer to the periodic table, and in the periodic table, if you sort out magnesium, you will find sodium on its one side and aluminium on its other side, and the electronic configuration of sodium is this, aluminium is this, and since in this case you have to write the negative ion as well, so you will search negative ion in series with magnesium. You have to refer to the periodic table. One is nitrogen, then oxygen, then fluorine, and but let's first answer this part. The cation, they have explained that cation are positive ion. So the 2 positive ion which has the same structure as Mg2 positive are Na positive and Al3 negative. And you can see Na positive, in Na positive, this one electron is lost, and the resulting is 2,8, which is what we are looking for, 2,8. And in Al3 positive, these 3 electrons are lost, so the resulting species is Al3 positive. So cation, these are the 2 answers, but you have to write a cation, so you can write any of the 2. Then it says the negative ion, so you have to follow the electronic configuration of uh, the negative ions. You have to refer to your periodic table. If you draw the electronic configuration N3 negative, why N3 negative? Because there are 5 electrons. In case of nitrogen in the outer shell, it needs 3 more electrons to attain stable structure. So it will definitely form N3 negative ion. So this is the electronic configuration, which is the same given in the question. Follow oxygen, it has electronic configuration of 2,6, but if you add 2 more electrons to get stable structure, it forms O2 negative ion. This is the electronic configuration. Fluorine has 7 electrons in the outermost shell, but if you draw the structure of F negative ion, which means the 1 electron is added to attain a stable structure, 2,8. So these are the choices, N3 negative, O2 negative, F negative, but again you have to write 1, and these are the 3 possible. In the periodic table, if you move on and draw electronic configuration, you will notice that in case of neon, there are 10 electrons and proton number is 10. So this is the electronic configuration which is given in the question. So neon is an atom. It is not an ion, it's an atom. Now you have to complete the table given in the question, and number of protons and number of electrons are same, so you can write 17 over here. Proton and electrons are equal, and if you work out you will see there are 20 neutrons. See the working. And then in case of Cu positive ion, the proton, again, I'm getting this thing from the periodic table. So this number is a proton number, which is 29. So you have to write 29. And it's a positive ion, which means one electron is less. So number of electron in this case is 28. Since it is positive, one less electron. Then there is an empty space. I have written S2 negative, but that I discovered later on. So following the periodic table, you will notice that sulfur is an element which has proton number 16 and mass number 32. This means number of protons are 16 and number of electrons in S2 negative is 18. See, you will notice one thing that protons and electrons are not equal. It's 16 and 18. How it is possible? Because definitely we are talking about ion of a sulfur, and if there are 18 electrons and 16 protons, so it means it has negative charge. So S2 negative is the species which I have written here, and I can further check these things. So this is my final answer.